the change that we saw from ChatGPT was just massive. All of a sudden, everyone's super interested in large language models. But yeah, ChatGPT just it kind of blew all expectations out of the water. Like everything, the amount of interest, the amount of people we saw signing up, it's just orders of magnitude bigger than what we were seeing before.
Hey, James, welcome. I want to thank you for being here. This is James Briggs, who is the Developer Advocacy Manager at Pinecone. He talks about AI. He has a great YouTube channel that I recommend checking out, and he runs an NLP consultancy specializing in the latest and greatest in the AI space. Welcome, James.
Thanks, Matt. Super excited to be here. Thanks for having me on.
Yeah, I'm really excited to talk to you. I learned about Pinecone a few months ago, and I want to know all about it. I want to know about vector databases, so you are the right person to talk to. Why don't we start with the high level? What is Pinecone?
Yeah, so a Pinecone is a managed vector database. So maybe I should go into what a vector database actually is, just at a high level.
Yeah, please.
So imagine you have, in fact, I'm sure we're all very familiar with those sort of internal company search tools, or at least I came across a few of those, a few companies I worked at. And basically, you'd have like a internal portal for your company, and they'd have like a little search bar, and you type into it, and just using that was generally a terrible experience. Like you'd have to get the exact keywords to match within your search query the document that you are searching for, which is it's not a very natural way of searching, because you are looking for something. You don't necessarily know the exact wording that is being used within that document, right? Instead, like we as humans, the way that we kind of discover or search for information is more based on like semantics or the meaning of that information. So when we ask someone a question, that person isn't answering our question based on the exact keywords we're using or the exact words we're using. Instead, they're kind of getting a feeling for the meaning of that question, right? And then they
Right.
respond accordingly, right? So for I think the best way of describing vector database is it supports that more human way of searching for information. It's not necessarily just language and text. You can search for other things as well. But rather than the more traditional keyword search that a lot of us are familiar with, it's a more intuitive, human-like search based on the meaning of what you were looking for rather than the keywords themselves.
So with a traditional database, let's say SQL, you're having to write specific queries that are searching for specific keywords or columns, tables, but with a vector database, it's much more like describing what you want. Is that a good way to describe it?
Yeah, it's more. It's almost like a fuzzy match between what your query and the documents. And also, in a SQL database, if you have, for example, like image data that you would like to search through or videos or something like this, that is not really very easy to do in a SQL database. Whereas with a vector database, you can also do that as well. You can type in, show me a picture of a really cute dog or something like that, and it will actually, if you implement it correctly, it will actually surface those images.
Got it. Got it. Okay. And so, like, how does the database actually work? So, if I'm a developer and I want to put information to be searched on later, relevant searches, semantic searches, what does that process actually look like? What am I putting into the database?
Yeah. So obviously it varies depending on what you're doing exactly, but the general workflow is for most use cases very similar. So On the fact that we're able to search based on meaning and semantics, that is thanks mostly or usually due to neural network models, right? So you can think of these, we'd call them embedding models. We can think of these embedding models as taking, in the language example, as taking our natural language, our text, and then encoding that into what we would call a vector representation of that text, right? So it's going from human readable text to machine or machine readable and numerical vectors.
What
Okay,
can
so
you actually elaborate on that for a second? What does that numerical vectors look like?
so imagine you have a like a 2D graph and you put some points on that 2D graph, right?
Hmm.
Each one of those points can be one of those numerical vectors, right? So this is in a 2D space. In reality, these numerical representations are high dimensional, right? So we're thinking hundreds, maybe even thousands of dimensions. But let's just stick with the 2D example and imagine that is the vector space we're using here. So you have these points and they are your vector representations of some text. In that vector space, 2 points that are closer together should, if done correctly, they should have a more similar meaning, right? And what exactly similar meaning means is kind of defined by the way that you train that embedding model. Okay, so there's some embedding models out there that do just like straight up semantic similarity. So they're going to match similar phrases together, right? And then there's other embedding models which maybe they've been fine tuned for question answering. So what they would do is actually match similar or questions and their relevant answers together within that vector space, whereas a vanilla semantic search embedding model would not necessarily do that. But the core idea is that within that vector space, vectors that are close together represent some text or something else that is similar in some way.
Okay. So let's say I have a string of text, like a poem. If I'm going to
Mhm.
store it in a traditional database, I'm literally putting that text, that poem, directly into a column.
Mhm.
Whereas for Pinecone, I'm converting that text into a kind of almost a vector, right? A
Mhm.
series of numbers, and then that
Yeah.
series of numbers gets placed in the database. Is that right?
Yeah.
And so you talked about embeddings. Does Pinecone itself handle converting text into an embedding to be placed in the database, or is that something that I would need to do myself as an engineer?
Yeah. So that's something that you would need to do yourself. So Pinecone, like the idea at Pinecone is that we want to be the very best we can be at the retrieval step, right? So that's the putting these things into vector space and retrieving them as efficiently as possible. That is what we want to focus on. So someone using Pinecone will have to create the embeddings themselves. We have a lot of recommendations based
Hmm.
on different use cases. And in a lot of cases, it's super easy to do, right? So, like if you are looking at English language text and you want to compare, you can actually just make an API call to OpenAI or some other service provider, or you can use what we would call a sentence transformer if you prefer to do go the more open source route. If you wanted to do multilingual search, the Cohere have a really good multilingual model. If you
Okay.
want to do text to image, we have plenty of models out there that can do that, and they generally speaking really easy to use. Um, in some cases, you may find that depending on your data, that you might actually need to fine tune or train some of these models a little bit. But for the most part, you can usually get a good feeling for if something is going to work with the off-the-shelf embedding models.
Got it. And OpenAI has an embeddings endpoint that you can use that would work with Pinecone, right?
Yeah, exactly.
Okay,
So
cool.
you call the OpenAI embedding endpoint. From there, you get your embedding, and then you send that over to Pinecone, and it gets stored in Pinecone, um, and it's there ready to be retrieved.
Okay, awesome. And so, to be honest, 6 months ago, I didn't actually know what a vector database is.
Mhm.
And ever since the announcement and proliferation of large language models, or specifically ChatGPT, a lot of people have been building projects that utilize Pinecone and other vector databases. So, what are some of the use cases where a vector database really makes sense within the context of building an artificial intelligence project?
Yeah. So yeah, I mean, uh, as you mentioned, like a ton of people have started using Pinecone since the more widespread adoption of LLMs, and within that context of LLMs and like AI more broadly, there's actually quite a few use cases of, for Pinecone, and many probably that we have not even thought about yet. So the main use case that we're seeing at the moment is using Pinecone as a retrieval mechanism to essentially give information or give knowledge to a large language model. So what you'll find with a lot of large language models is if you begin asking harder questions, or if you begin asking questions about recent events, or you begin asking questions about maybe like as a company, you have internal data sets. If you begin asking questions about that stuff, it obviously can't actually answer those questions very well or all, right? So it
Mhm.
hallucinates, which is it begins to make things up. And
Right.
that's a very big problem with LLMs. And vector databases like Pinecone are one of the ways that we can combat those hallucinations. So it essentially works by taking your query that you'd usually pass straight to the LLM. You actually send it to Pinecone instead. Pinecone returns a set of relevant context. So imagine like maybe you have like 5 paragraphs of information that is relevant to your query. Maybe that is coming from like internal company documents, for example. And what you then do is take your original query, you append those contexts to it, and then you pass all of that into your LLM. And then that new, like larger prompt gives more information to the LLM so it can actually answer your question accurately. So it's essentially a way of feeding in more knowledge into your LLM beyond just training it. Because most of the like if you're just prompting an LLM directly, you're relying solely on a parametric knowledge, which is the knowledge it has learned from the training data. Using Pinecone, you have another um, way of getting knowledge into that LLM. So the source knowledge, um, which you can keep up to date. You don't have to train the model on it. So it's just an easy way of getting that information in there.
Okay. Yeah. So when I think about vector databases, I think about it almost as giving large language models both memory, so long-term memory, but also giving large language models the ability to have much larger context sizes because context sizes are quite limited.
Mm.
And so if let's for example, you have a huge PDF, hundreds of pages, maybe even thousands of pages, and you want to ask questions about or to that PDF, there's no way to give the large language model the entire context of that PDF. So
Mm-hmm.
one thing you could do is translate that PDF into a vector database, into an embedding. And
Mm-hmm.
then, like you said, you're asking Pinecone, you're saying, hey, I want to know about this, and then Pinecone gives you the relevant pieces of that 1,000-page document, and then those relevant pieces get put into a context, into a prompt, and then the large language model gives you what you're asking for. Is that a good way to describe it?
Yeah, it's perfect.
Okay. And I mean, what are there other use cases that, as an engineer, I should be thinking about using Pinecone and vector databases for?
Yeah, I mean, in reality, vector databases or just more broadly vector search is kind of used everywhere, right? So obviously, Google search is a relatively obvious example. They've been
Right.
using this sort of technology for a long time. But then there's other maybe more subtle examples of that in the technology that we use like day in and day out. So like Netflix, they're recommending new shows to you, new
Ah,
movies to you. That's just a vector search. So they're basically converting you based on your watch history. They're converting you into a vector, and they are looking at other users and their vectors and looking for users that are similar to you uh, within that vector space. And then they're looking, okay, this other user has watched these, 5 TV shows and they loved it because they just didn't stop watching it for the whole week. So, and you haven't watched any of those TV shows. So now they're going to recommend those to you, right? So that's one other very broad, like very widely used use case of vector search, and we see that everywhere. Like Amazon products are recommended that it's also vector
right.
search. Um, Spotify, when it's recommending music to you, again vector search. So we really do see it kind of all over the place.
So one use case that jumps out to me is if I have a website. Previously, before I really learned what a vector database was, and specifically how easy it is to use them, specifically Pinecone, uh, if I wanted to give a way for my users or my visitors to search through the content on my website, if I have a SaaS product to search through the features or anything, that was kind of a difficult process. Uh,
Mm.
but like ever since I started using Pinecone, I realized how easy it really is. So it's really exciting. As a developer to have that relevance search or semantic search at my fingertips in any project, like super easy. Yeah, I think that's a really obvious use case as well.
Yeah, anywhere where you have search is, I think, a huge use case for using a vector database. And it's, yeah, like you said, I remember like just a few years ago, implementing search well was so difficult.
Yeah,
And now, like you can do it you can do it in the morning very easily. Like that, and the hardest part is not the search; it's like getting all of the data prepared and all these things.
yeah.
In terms of the actual search, it doesn't really take any time at all to build out that function.
Yeah, I mean, at my previous company, we you can think of us kind of as a CRM, and we wanted to have search functionality where somebody can type in anything about one of their customers, and it would pull up that customer based on any of the properties, their contact information, message history, and we used Elasticsearch, and it was actually pretty painful to use.
Mm,
It really wasn't simple. Some of the queries that we had to write to get it to work, and maybe that's changed. We built it years ago, but it was very painful. And then, again, when I started playing around with Pinecone, I was like, oh my God, this is so applicable to that use case. And this took me 5 minutes to set up. And yeah, it would have taken a little bit longer given the data set size, but it's just so straightforward. So that it is really impressive.
yeah, yeah. I also I was using Elasticsearch a while back, and I had the same experience. There's just so
Yeah.
many like parameters and things that you
Yeah.
can change, and it is it is hard to get it working and working well. And you're also stuck, even with Elasticsearch. What you're actually doing there is that more traditional style of search. You're using BM25 and some good TF-IDF, which is basically you're matching up those keywords, right? So
Right.
it's harder to get it working, and then you're also limited in the respect that you're not searching based on the meaning again. You're just searching based on keywords.
So it's interesting. I'm thinking we probably implemented Elasticsearch, 6 years ago, 6+ years ago. How long has Pinecone been around for?
So the company itself, or the development on the product itself, has been going on for, I'd say, maybe 3.5, maybe 4 years now. But we actually, the Pinecone that most of us would recognize was released roughly, I would say, a year, almost 2 years ago.
Okay. And James, how long have you been at Pinecone for?
Almost 2 years again. So I came across Pinecone whilst doing some freelance work, and initially they were one of my freelance clients.
Yeah, I'm excited to ask you about this. You've been at Pinecone for a little while. You were at Pinecone when not a lot of engineers knew about what Pinecone was or even what a vector database was. Uh, and all of that changed at the beginning of this year. And I want to know, first of all, what was it like before the beginning of this year? And what was it like when people started to figure out, oh, databases are super useful, especially for large language models. So talk to me a little bit about that journey from before, during, and what it's like now.
Yeah. So I mean, yeah, things definitely changed a lot. There's kind of like a pre ChatGPT era and a post ChatGPT era. So yeah, when I joined, or at least when I began the freelance work with Pinecone, I'm not sure how many people there were, maybe around 10 at most. But yeah, the
Wow.
team was very small back then. And then I joined full time, like around 20 people. So still, like compared to now, a much smaller company. So yeah, when I started, just when you said vector database or vector search, there were very few people in the world that knew what that meant. It was pretty much purely people that were working in information retrieval, and even a lot of them did not know. So, like, you would go to an information retrieval conference back then, and literally no one would talk about vector search. Maybe like there'd be two people like that mention vector search or semantic search, but it just wasn't, even back then, even between information retrieval people, it just wasn't really a thing that anyone really spoke about. So yeah, it was, my job was basically to get the word out there that vector search was a thing, and to kind of show people how to use that. So that was a really interesting experience, and it really was like starting from nothing. So yeah, it was a lot of fun. But in terms of actual, people coming to us, like being aware of what vector search was, that there was literally no one. So the first job for us, with everyone coming in, was, okay, this is what vector search is. We'd give an explanation, kind of like the one that I gave a little bit earlier, and that would be our first task. And then at the same time, the things that we were talking about were not probably what most of the people watching this and yourself would think of when it comes to vector search, or vector databases. It wasn't, AI, large language models, OpenAI, and all this sort of stuff. It was those more kind of traditional use cases, like the recommendation systems, the just pure semantic search where you're looking for results in the traditional way, right? So what we were talking about was very different, and yeah, the audience was also much smaller and very different as well. Then we started, maybe it was in, I think it was around May of last year. So May before ChatGPT, we started working more closely with OpenAI, and I got to work with a couple of their engineers, and they showed me basically what you could do when you put Pinecone and OpenAI together, and my mind was just like completely blown. Like it
Oh
was
wow! So you had access, or you were looking at this new product before the world knew about it.
no, this is just GPT-3. So GPT-3, everyone had access to it back then. It was
Okay,
just
okay.
it was just a case of okay, putting them both together. We knew, or I knew we could do it. I think I'd even created a few examples of it before, but they showed me how to do it properly. Like basically like the what we'd call prompt engineering now. They just went in, modified all the prompts, made it look good, and that just completely changed the performance of it. Like what you could do with good prompts, and then adding in GPT-3 at the time and Pinecone was just insane. Like I was, yeah, completely mind blown. I mean, really up to that point, I'd been focusing a lot on like question answering, and the question answering use cases that we were doing were just we call them extractive. So you would basically search, you'd get like five results, and you'd extract the answer from those results. You basically say, okay, this is the starting word for the answer, this is the end word for the answer, and that's your answer.
Yeah.
And already that was really cool. Like we went to OpenAI, we did this stuff, and okay, we would get better, like incredible results, and we could say, okay, give me this answer in a bullet point list, or just summarize this in two sentences, or go into details, pull out the main Python libraries that are mentioned in these answers, and all this sort of stuff. And I was just, it was so far beyond what I had seen before. I was really, really impressed. And then fast forward, like we use OpenAI and other like Cohere and other providers a fair bit in that time. But we fast forward a bit to ChatGPT, and that's is when like everything just completely changed. Like all of a sudden, it seemed like the entire world was talking about this stuff. Um, so like I remember, yeah, I think for New Year's, I was in the Philippines with a friend, and it was like a New Year's party or something, and there were all these people that were doing, I think they're doing SEO or marketing or these really like random things, and they were not like not the sort of people that I would expect to be involved within the AI space whatsoever. And then just all of them were talking about ChatGPT. And I was like, that's like to me, it's like what this is so weird. Like everyone's talking about like the space that like I'm involved in. Like why are people talking about this? No one is usually interested. It's crazy.
So
Um,
so you went from going to a data retrieval conference, which those, the forefront of using this type of technology, and nobody was talking about it. And then you go to a meetup of people who shouldn't know about what a vector database is, what a ChatGPT is, and they are talking about it.
yeah, exactly. Like within the space of, I mean, that's probably within the space of maybe like 4 months. Those two things, right?
Wow.
It's yeah, the change that we saw from ChatGPT was just massive. All of a sudden, everyone's super interested in large language models, and then all of a sudden, everyone's like, okay, we have this issue with hallucinations. They're not up to date. They can't answer questions about our, niche domain or anything like that. And then obviously people are like, okay, how do you fix that? We fix it with a vector database, and then all of a sudden everyone knows about vector databases. Just really out of nowhere. It's yeah, the amount of like the change before ChatGPT and after ChatGPT is just completely insane.
So I want to hear what it was like inside the company, inside Pinecone. The energy during those early days post ChatGPT launch must have been insane. What was the energy like? What were the conversations like? Were people surprised, excited? Tell me about that.
Yeah, so I think to some degree we were aware of the whole AI and vector database um, like synergy. Okay, we knew that vector databases would be a key component of the future of AI for sure. But yeah, a ChatGPT just it kind of blew all expectations out of the water. Like everything, the amount of interest, the amount of people we saw signing up, it's just orders of magnitude bigger than what we were seeing before. And we were
That's so
we were
cool.
happy with what was happening before. Like it
Yeah.
was going great. And then all of a sudden you just have this massive influx of people all like using AI and coming to Pinecone. So yeah, for us it was just I don't know, like a crazy time. It still is a crazy time. Like that hasn't calmed down. To be honest, we've just kind of become adapted to it. It's like, oh, this is the new normal for us. We're like, okay,
Right.
this is just how it is now. Um,
Okay. ChatGPT launches, craziness ensues. You're getting a bunch of people who are talking about vector databases, who are building things on top of it. I suspect another huge inflection point was the launch of AutoGPT, which by default, the original version plugged into Pinecone. Is that accurate?
yeah, that was another big event. So yeah, after ChatGPT, we saw this like insane exponential growth. And every week you're thinking, okay, it's gonna slow down, right? And then it's just the next week, it's like, oh, you can't even see last week on the graphs anymore. It's just not there, right? And then the next week it happens again, and you're like, this is okay, okay, it keeps going, right? And we saw that sort of crazy exponential growth between it was about a month after ChatGPT, right? We saw some like gains in that time, like the month of December, but it was the month after that we saw a lot of the growth. I'm not sure why that is exactly. Maybe took people a bit of time to make the connection between vector databases and LLMs, or maybe people just got back from the holidays. I'm not sure,
Yeah.
but yeah, that's where we started seeing that. And yeah, we saw this exponential growth, kept going. And then I remember like it was probably like the first like full weekend I had off for a long time. I like completely like shut down everything. Like I wasn't checking Slack or anything. And then like I came back on Monday and I was just it was like early morning, so I was just looking and I was like, oh, people are well, there's loads of new people. Okay, that's the same as we've seen that for ages. I don't know why people are talking about it. Um, and then I go into like our analytics. Like it's like one day, like I've noticed a massive spike above everything else, right? So this single day just kind of dwarfs everything. Um, and I'm like, okay, well, where has this come from? Like, do people know about this? And I go back into Slack and I'm checking, and I'm like, okay, this is what people are talking about. There's this auto GPT thing, um, and then yeah, that's kind of how I discovered it. It was just this massive, like, crazy spike in users from auto GPT, And that first day I remember was like insane, the number of new users that signed up. But then the next day was even more insane, and that kind of continued for a while. And we were like, okay, I mean, do people really need Pinecone for this? I think the number of embeddings on average that someone using AutoGPT was creating was like 10, which
Right.
you don't, you can store them locally. It's not, it's not a problem. So we were like, okay, maybe Pinecone isn't a good use case for this, and we help them implement some other alternative options um, to
Wow.
kind of help out on that case. But it was kind of, you were using Pinecone for that. It's like you're using something very overpowered for something smaller. So it wasn't needed. So things calmed down after we switched out those defaults. But yeah, that was a big moment as well.
Yeah, and so for those who don't know, AutoGPT is essentially a way to have ChatGPT almost run itself, right? You give it a high level objective, and it continues to iterate, plan, put tasks together, prioritize those tasks, and it'll just continue without human input if you want to run it like that. And it was really the first time people looked at it and said, "Oh, this is kind of what the architecture of AGI might look like in the future." And quickly, within a few weeks, it became the most popular repository on GitHub ever. And so, yeah, you kind of were perfectly aligned to ride that popularity. Um, I find it commendable that you looked at it and you said, "Hey, maybe this isn't the best use case for Pinecone. Let me give you some other options." Now, probably when somebody reaches large scale, needing a vector database, Pinecone is a great option for that.
Yeah, so I mean, what we see as the real use case for like AI as and Pinecone as that sort of external knowledge base or the memory is more for those larger use cases, right? If you're looking at like 100,000 or millions or even billions of items that you'd like to store, that's when you want to be using um, a vector database like Pinecone and AI.
And so if you're doing something on a smaller scale, are you still using a vector database, but it's just not Pinecone? It's maybe something local, or do you even need a vector database? What are your thoughts there?
So it really depends on what you're looking for. So if it's something small, like maybe you have 10,000 items, or even smaller, you could just use like you can use like a NumPy array and just
Hmm.
you have your NumPy array of all of your embeddings. You have your search item, convert that into an embedding, and then you just do like dot product similarity between them. Okay, and then you are finding the embeddings in your NumPy array that have the highest similarity to your query. Right, so you can
Okay.
just do that, and that's I don't know what is that, like a few lines of code. It's not much, and yeah, it's relatively straightforward to do. Now, for all smaller use cases, like I'll be honest, I still do use Pinecone fairly often
It is
because
quite
it's
easy to
just
use.
yeah, it's just super easy to use.
Yeah.
Like it's hosted like it's a managed service, so you don't need to worry about any of that stuff. It has like filtering. You can do like hybrid search. You can do all these different. You have access to all these different features that you wouldn't necessarily get out of the box, at least with like your NumPy array. So yes, generally speaking, in reality, you should be using a vector database for those bigger use cases. But in some cases, it's just kind of nice for it to just work straight away and to have those extra features in there as well.
And so let's continue talking about like the right use case and specifically, we're talking about scale being the best use case for Pinecone. Um, one question that I've been thinking about is as large language models context sizes continue to grow, right? I think Claude is 100K. There was a research paper where you can have a couple million tokens um, in a single prompt. There's definitely performance trade-offs at those sizes, but I suspect context sizes will continue to grow. As that happens, what does that mean for Pinecone?
Yeah, it's a good question. So, in terms of the context sizes and the increase in context window, like that's a very good thing for these models, and like I'm very happy that that's happening. As you mentioned, there are like performance issues at the moment. So what you tend to find, even at smaller, even if you're feeding like 2,000 tokens, if you give like instructions to GPT-4, GPT 3.5, you give some instructions, you ask a query, you then pass in like 2,000 tokens of context, it can sometimes struggle to just follow your original instructions.
Right.
It's almost like it forgets, even though you are fitting all that information into the context window, it does seem to be more forgetful. Now, let's imagine, okay, that performance issue is no longer a problem. The anything you put into that context window is followed perfectly by the large language model. In that case, so we have like 100,000 tokens at the moment from Claude, as you mentioned. Like that isn't that's really on that smaller scale of
Right.
what you would use a vector database for, right? So almost like the NumPy array example, like you probably just use that at that point, right? Even if you get up to a million tokens, right? It's still not actually that many items, right? We like a small use case with Pinecone, like a very small use case, is like a million embeddings, right? Maybe you can go
Wow.
down to like 100,000 embeddings, right? An embedding that can contain that can contain itself like a few thousand tokens. So in terms of like where they overlap, sure, I would say overlaps with the very small use cases, but in reality, like as a managed vector database, what Pinecone caters for is those larger use cases. And long term, I don't, I personally can't imagine the context window scaling or scaling as efficiently as what you can do with a vector database. And then there's other issues that you have in there, like just keeping everything, like all the data managed as a database is, it's easy to do with a vector database and all these other um, like controlling what is going into the context window, what you need to remove or update, and all these things. So yeah, there's some overlap, but I would say it's more on those smaller use cases than anything big.
Yeah, so like I'm thinking about the large use cases. Some of the biggest companies: Facebook, Google Search, YouTube Search. There's no possible way to fit that in a single context or single context window in an LLM. So there, that is the scale at which Pinecone really excels. It sounds like.
Yeah, our sort of the product of like vector search with Pinecone is really looking at those bigger um, use cases. And when we say bigger, um, and we say like okay, 50 million embeddings, that's not even necessarily that big. I suppose
Okay.
big is more like on the billion scale.
Okay. Okay. Got it. I want to change gears for a second, and one thing that I just sounds so futuristic and exciting to talk about is AI memory. What it actually means to give artificial intelligence memory, um, and what I keep hearing LLMs are stateless. I would love to know, like, what does that mean, and what does it mean to give AI memory?
Yeah. So in calling LLMs stateless, what we're referring to there is the fact that so an LLM, you train it on a very large data set of, of text, right? And there's some other like fine tuning approaches that are used there, but essentially what you get at the end of that is the LLM, its world or the way that it understands the world is kind of frozen in time based on whatever the end date for that training data was. Okay, so beyond that, it doesn't know anything about the world, right? So that's a parametric knowledge of the LLM. And when you make when you prompt the LLM, right, it's giving you an answer based on that parametric knowledge. And then it gives you the answer. When it just forgets that it just gave you the answer, it doesn't like there is no persistent memory between different responses or queries from a user.
Right.
So, and that's also true for the chatbot models as well. So the way that they get around that with the chatbot models is you actually, with every new query, you're actually feeding in all of the previous interactions between the user and the AI as well, right? So you have that is what you'd call conversational memory, right? So you have all those previous interactions. The last interaction is the question that you are giving to the LLM, and then it's going to give you a response, which basically just looks like a response in a conversation. So even in that case, they're still stateless. They don't have any like genuine memory in there. So they're kind of like two, or that's one form of conversational memory, and then we have that parametric knowledge, which I suppose would be kind of like the training memory, the model. And then the other one, which is where the vector database comes in, is the what would we refer to it? It's the like external knowledge base. So the external knowledge base in the context of a vector database is where you have this managed database. So you can basically put in all of your records. So you have vector that's attached to your text or whatever else you want to feed into your LLM at some point. And the LLM can basically just refer to the vector database for more information, right? And you can keep that information up to date. You can keep it. It can be based on your like internal documents or whatever else. So it's essentially like a window into the world for the LLM, right? And we like in terms of the like whole memory naming thing, we've given that the name of long-term memory. Whether or not long-term memory sticks, I don't know, but that's what we're calling it for now. But in reality, it's probably better to think of it as a window into the world or the world that you are defining. Obviously, it doesn't need to see all data in the world. You can restrict it to whatever it is you're wanting to restrict it to.
Okay, so you have a large language model. It's trained on a huge set of data. And then as soon as that training is done, it does not have any additional information. One way to give it additional information is to pass it through the context window, but there's limitations there. Another way is to use a vector database, right, to store that information and query the relevant information and pass it to the large language model. A third way is to fine tune. You can give it additional context or additional information by fine tuning it on specific training data. But of course, that's costly in terms of both time and GPU resources. So is that a good description of the kind of the three ways to give LLMs additional memory?
Yeah, I would say so. There are other things you can do as well. So something that we've seen more recently is the use of like agents or tools, and this is more a way of giving it access to the external world, so you can actually allow them to do a Google search and retrieve information in that way, or to make API requests to some service. Right. So there are also other options of getting information into the LLM, but at its core, there are three like ways that you can categorize all of those methods into three different ways of getting information or knowledge into the LLM, which is the parametric knowledge, which is from the initial training, the source knowledge, so when you're feeding information in via the prompt, and then fine tuning, as you mentioned, which is adding more information or knowledge to the parameters of the model.
So, a last question on the AI memory side. Is memory required to reach artificial general intelligence?
Yeah, it's an interesting question. I would like to think yes. Um, I remember, and I'm not sure if this is accurate, but in from what I remember, there's a film called, is it Ex Machina? Have you seen
Yeah.
it?
Yeah. I love
Yeah,
that movie.
and I actually watched that pretty late. I watched it within the past like 2 years, and maybe I was just projecting what I know onto it. Um, yeah, I definitely was. And all I remember is that the guy that builds the the AI, like the company that they have built, is like a search engine, and the thing that powers the AI is the search engine with some other fancy things on top. So I was like, okay, this is what is going to happen. We're going to have some sort of retrieval engine. It's going to be a vector database, and then we're going to have the AI language models on top controlling everything, and that's how we get there.
All right. Well, thank you so much, James, for talking to me. This has been really interesting. I love learning more about vector databases, about Pinecone's story through that transition. And if you want to check James out, it's James Briggs. You can search for him on YouTube. He's also a developer advocacy manager at Pinecone. Also check out Pinecone. I'll drop his YouTube channel link in the description. I'll drop Pinecone in the description. Check it out. Even for small projects, I'd still recommend it because it's super easy. And yeah, James, thank you so much for your time today.
Thank you so much. Thanks for having me on.